So today, lesson 9a, solutions to a linear equation. Part of our focus in this unit has been graphing linear equations. And actually, all of those 7th grade equations that we solved in the pre-unit 1, those are all also considered to be linear equations. But our focus today is trying to determine whether something is actually a solution to a linear equation or not, and then kind of describing how that might work. Okay? So, we've gone in full detail, and this is where we start filling in the blank areas. What we mean by an equation that is in slope-intercept form. If we have an equation that looks like that, in other words, in the form y equals mx plus b, that's called slope-intercept form because we know what the slope is, and we know what the b value of the y-intercept is. And the reason why that's important, as you found out yesterday, is because if you know those two pieces of information, it's very, very easy to graph an equation. Now, what we're going to find out tomorrow is that not all equations are already in that form, and then we'll kind of talk about how we graph equations that are not in that form. Okay? So, any linear equation which is solved for y is in slope-intercept form. Also, we know that if we graph it, the graph will be a line. Okay? And that's what a linear equation is. An equation whose graph is a line. All right. So, I'll do number 1 for you, and then you will do number 2, 3, and 4. So it says find the slope and the y-intercept of the following linear equations. And number 1, clearly, m is 3, or the slope is 3. And the y-intercept, or the b value of the y-intercept, is positive 4. Can you quickly go ahead and do number 2, and 3, and 4? All right, so those should have been easy. Number 2, m is negative 2, and b is negative 1. And by the way, notice that I'm adding the ordered pair that b leads to on the graph. Can you go ahead and add that to your notes? So like when b is 4, we know that 0, 4 will be on the graph. When b is negative 1, we know that 0, negative 1 will be on the graph because that's what the y-intercept is as an ordered pair. Number 3, the slope is 5. We know that b is 0, and so that means 0, 0 will be on the graph. And then number 4, m is 5/8, or the slope is 5/8. b is negative 4, so that means that 0, negative 4 will be on the graph. So now we're going to go backwards. What if I give you m and b, and I ask you to write the linear equation in the form y equals mx plus b? I'll do number 5, and then I'll have you do the others. If m is 2 and b is negative 3, clearly the equation would be y equals 2x minus 3 in slope-intercept form. You now go ahead and do 6 through 9. Easy. Number 6 should be y equals 2/3 x plus 5. Number 7 should have been y equals negative 3/7 x plus 2. Number 8 should just be y equals negative 2. We don't really want to write in 0x because if it's 0x, that means there shouldn't be any x's there. What's that?
On our papers, the y-intercept is 7 is 5, not 2.
All right, thank you. So that's every time you guys see a typo, just let me know so I can get it fixed. So thanks for letting me know on that. And then number 9 would be just y equals negative 1/2 x. So is it just number 7? Yeah. Okay, all right, thanks. All right, turn the page, please. Now, number 10, the question is 4, 7 a solution to the equation y equals 3x minus 5? There's 2 ways to think about this. One is, will that point be on the graph if you were to graph it? Or will that ordered pair make a true statement? Well, a solution of an equation is an ordered pair of the values x, y that makes an equation true. Remember from 6th grade, all ordered pairs are in the form x, y. So if x is 4 and y is 7, will that make a true statement? Anybody know? You should be able to do that in your head. Yes or no?
I don't think so.
You don't think so?
No, because 3 is 3x.
Well, I actually think it does make a true statement. So what I'm saying is this. This is an x value. This is a y value. So if you plug 4 in for x and 7 in for y, we get this. What I'm trying to do is do it step by step here. So remember, 3x means 3 times x. That's from 6th grade. And then we're going to substitute 7 in for y right there. And 7 is equal to 3 times 4 minus 5, because 12 minus 5 is 7. So what that means is two things. 4 comma 7 is a solution, and if we were to graph it, we know that 4 comma 7 will also be on that line, because all graphs of a linear equation, the solutions all lie on the line. Okay? All right, so once again, yes, 4 comma 7 is a solution to the equation y equals 3x minus 5. Could I get all of you to try number 11? But number 11, is 2 comma negative 2, is that a solution, yes or no? No. I mean, it's very simple. If you plug 2 in for x and negative 2 in for y, if it makes a true statement, it is. And if it doesn't, then it's not. And in this case, when we substitute those two values in, that does not make a true statement. That's not a solution. And so also that means 2 comma negative 2, if you were to graph y equals 2x plus 4, it would not be on the graph. All solutions of a linear equation, if you graph it, will lie on the graph. Now, number 12, we are asked to select all the solutions. So we need to figure out which of those 5 will make a true statement. Could I get everybody to do number 12, please? Second, there we go. Is 5 comma 14 a solution, yes or no?
Yes.
All right. If I substitute 5 in for x and 14 in for y, that is a true statement. How about negative 1 comma negative 6?
No.
All right. No, it's not. Okay, we can see it right there. How about negative 2 comma negative 2?
No.
Okay, that one is not either. How about 2 comma 8?
Yes.
Okay, I heard a few no and mostly yes. Which one is it?
Yes.
It is yes, yes. And that's the reason why. How about negative 6 comma negative 8?
Yes.
All right. And that one is as well, because we have negative 12 plus 4. That is negative 8. All right, go ahead and do the same thing for number 13. Select all the solutions below that satisfy the linear equation. Negative 1 comma negative 1. Solution, yes or no?
No.
Okay, very good. How about 6 comma negative 27?
No.
How about 2 comma 5?
Yes.
All right, very good. How about 12 comma negative 32?
No.
All right. And how about 5 comma 17?
Yes.
All right, excellent. All right. So now, let's shift to graphs. List 3 solutions found on the graph below. Well, I've already mentioned it 3 or 4 times today, that all solutions to a linear equation are found on the graph. So could somebody give me one solution for this linear equation that is graphed for you? Yep. 0 comma 1. Okay. So in other words, right there. Somebody give me another one. Yep. 4 is just a number. That's not an order pair. Well, but 4 comma 1's right here.
1 comma 4.
Yeah, we got to get them in the right order. It's x comma y. Left, right, up, down. So right there, 1 comma 4. Can somebody give me another one? Yep.
2 comma 7.
Now, I only asked for 3, but could somebody give me another one?
3 comma 7.
And I didn't ask for this many, but could somebody give me another one? 4 comma 13. So how did you know the 4 comma 13 was on the graph, even though it's clearly not showing on the graph? How did you know that?
Because it's increasing by 3 each time.
So you're noticing the pattern there, right? Remember, all linear equations that are graphed, they go on infinitely in both directions. So if you just keep going with the pattern, as she said, 4 comma 13 would also be on the graph. What would be the next one up from that if I did ask you for it?
5,60.
Excellent. Excellent. Okay? I only asked for 3. There's 6. There are an infinite number of solutions to that, but I only asked for 3. So could I get you guys to now do just go ahead and do number 15. That's the next one. Can somebody give me one, please? I don't know how many are visible, but I know there's more than 3. Yep.
0, -5.
0, -5. Okay. That's right here. Another one.
2,
2,
-6.
-6. Very good. Oops. When you said 0, 5, did you say 0, 5 or 0, -5? Okay. I forgot to write down the negative. Raphael?
4, -7.
4, -7. All right, and I think you guys get the idea. This one there's a whole bunch of them that are actually visible. I only asked for 3. Okay. All right, so the last idea for today is actually where we need to create 2 solutions and then use those solutions to graph. Okay? So, could somebody give me one solution to this linear equation? There are an infinite number of solutions. I'm only asking for 2. Yes.
8.
What's that?
8 for x.
Did you say 8? Well, that won't fit on the grid if we use, or will it? 8, comma 19 won't fit. So we don't really want to use we need to make sure that they actually fit on the grid here.
Okay.
Yep.
3, 4.
3, 4. All right. So let's write in 3, 4. And the reason why it works is because 3 times 3 is 9. 9 minus 5 is 4. Now, and this is where you need to pay attention because this is how you need to do this in MyOpenMath. When you put them in the table, whatever you put in the table, you then need to use the dot tool to plot a dot. Okay? Because what MyOpenMath is doing is it's checking to make sure that whatever you put in your table is also on the graph. All right, I just need one more. There are an infinite number, yes.
6, 8.
But 6, 8 won't be a solution. Because look, if you use 6 for x, we've got 18 minus 5. That's not 8.
It's not proportional.
Well, it wouldn't be proportional
No,
anyway.
I think what she was trying to do was just do mine, but doubled.
Got it. Yep.
5, 10.
5, 10. So, of course, I'm going to check to make sure that that works. But if x is 5, 15 minus 5 is 10, so that one definitely works. And so let's go ahead and plot that ordered pair, 5, 10. And that one is barely on the grid, but it is. And so you use the dot tool in MyOpenMath to plot the 2 dots, and then you'll use the line tool to select here, and then it will automatically draw that line through there for you. So when you're doing this in MyOpenMath, once again, MyOpenMath is checking, is 3, 4 on the graph using the dot tool? Is 5, 10 on the graph using the dot tool? And then you're going to use the line tool to draw a line all the way through. Okay? All right. Can I have all of you guys do number 17 all the way through? Okay, so let's come up with a couple of solutions here. Somebody give me the easiest one. We already talked about it. What's the easiest one?
0, 2.
0, 2. All right? And once again, MyOpenMath is going to check to make sure that you have 0, 2 in there. And I'm just waiting for this to catch up here. All right, so 0, 2. 0, 2. What's the next, probably the easiest ordered pair?
Y,
Sure.
6 and -8.
6, -8 won't work because if x is 6, -6 plus 2 is not -8.
5, -3.
5 comma negative 3. Now 5 comma negative 3 would work. But here's what I was trying to say earlier. Let me get rid of this. What's the slope? It's what? What's the slope? It's negative 1. Somebody said negative 1x. X wouldn't be part of a slope. The slope is negative 1, which in terms of rise over run means a rise of negative 1 and a run of 1. So you could, from that ordered pair, rise negative 1 and run 1, and look. A lot of you did use 1 comma 1 as your solution, but you can sort of piece all of these things together. Start with your y-intercept, and then use the idea of slope to find another solution. Okay? A few of you are, I think, making this more complicated than it actually is. All right, go ahead and turn the page, please. Should be on number 18 now. Everybody try number 18. All right, so let's take a look at number 18. We know that this y-intercept is 0, negative 1. If you're going to use the slope, what would be one possible solution that you could use next? What would be one? Now, I say one because there's actually two, because you could go up and left, or you could go down and right. Either one of those. Yeah. 1 comma negative 6. So let's see if that's right. So you went, 1 negative 6 is right here. So that means, remember, slope is negative 5, which in terms of rise over run means negative 5 over positive 1. So you went down 5 and right 1. Very good. What if you went the other direction? What would it be, Tommy?
Negative 1, positive 4.
So I'm just going to go ahead and put it right here. Negative 1, positive 4. Because if you went instead, remember, positive 5 over negative 1, or a rise of positive 5 and a run of negative 1 gives you the same slope. Because negative 5 is the same as negative 5 over 1, which is also the same thing as 5 over negative 1. So up, 1, 2, 3, 4, 5, and then left 1. So either one of those would be fine. Okay? Quickly do number 19. All right, so the y-intercept is at 0, 0 because b is 0 or because that's a proportional relationship. Using the dot tool, we'll plot it there. And then you could, if you want to use the slope, m is 1/2, so that means that's a rise of 1 and a run of 2. So that would take us right there. We could also think of it as negative 1 over negative 2. If you did that, that would be a rise of negative 1 and a run of negative 2, which would take you right there. But 1 comma 2 is, or excuse me, 2 comma 1 is probably easier. All right, so I don't think we need to do number 20. I am going to have all of you try number 21, and we'll end it with number 21. All right, so let's take a look at this one. Clearly, b is 3, so the y-intercept is 0, 3 as an ordered pair. M is negative 1/4. Now remember, that means the same thing as negative 1 over positive 4, or positive 1 over negative 4. Your choice. It does not matter. Plotting 0, 3 takes you here. And then I'm going to go with the rising negative 1, running positive 4. So that means down 1, right 4. And look, a quick check. That line better be going downhill from left to right. Yes? How do I know it's supposed to go downhill from left to right? Negative slope, exactly. These are all little checkpoints that we have along the way to make sure that we're doing the right thing. Okay? All right. That is it for today.